All right, so today we're going to work on the next 2 days. The notes are going to be over operations on fractions. Now remember, when I say operations, I'm talking about 4 things. I'm talking about what 4 things when I say operations? Kelly? Good. Multiply, divide, add, subtract. Those are our 4 operations. So, adding and subtracting fractions are the only 2 parts that we're going to talk about and deal with on our notes today. We're going to have 4 rules when we add or subtract fractions. The first rule says change or both fractions, change one or both fractions so that they have a, what do you guys think? What do both fractions have to have? The same denominator, so a common denominator. Now, I understand that you guys as calculators will formulate and solve fractions for you, but I still want you to have the notes, and I still want you guys to have the background information for you. Just in case you're at home and you forgot the calculator, or you're somewhere else and you don't have a calculator, that way you at least have some of the basic understanding of how to add or subtract fractions without a calculator. So, once you have a common denominator, you add or subtract the blank according to their signs. So after we get the same denominator, what do we do next? We add or subtract the numerator according to their sign. Now, I know you guys have done this. I know you did this last year with Carlos and Nimmons. I remember seeing worksheets. Once you add or subtract those numerators according to their signs, we keep the what the same? Not the sign. So let's say we now have this. That's a really bad example. I don't want to use that example. Hold on. Okay. So my denominators are the same, right? So I add or subtract my numerators. Well, this one it says add. And then I keep the what the same? The denominator, yeah. And then the last step, anytime you deal with fractions, any single time, you always have to make sure you do what with fractions? This is, yeah, simplify. I don't like this word. I don't let my kids say it. But I always say fractions suck because you have to simplify. So that's how I always remember. And I know it's not the most proper way to remember something, but it works for me. Okay, so we have our notes. So after we have our basic notes, we're going to flip our sheet over and we're going to do 4 example problems. That's all we're going to do today. Now tomorrow we're going to hit it hard. How many example problems do we have tomorrow? 8. So only 4 today, but 8 tomorrow. Okay, you guys ready? Example number 1. Go ahead and write this down next to example number 1 under add, subtract, practice. You have 2/5 plus 1/5. The first thing that you're going to check, 2/5 plus 1/5. The first thing you're going to check to see if they have a common denominator. When I say denominator, I'm talking about that bottom number in a fraction. So, do they have a common denominator? Are their bottom numbers the same? Yes. So there's step 1. It's done for us. Move to step 2. Add or subtract the numerators based on whatever the sign is. So if I'm going to add, because my operation is add, I'm going to take 2 plus 1, which is 3. Step 3 says to leave my denominator the same. So what's my denominator? 5. And step 4 says to simplify. Now, I always check to see if I can simplify by 2, 3, or 5. Can I simplify this by 2? Are both of these numbers divisible by 2? Are they even numbers? Mm-mm. Can I simplify them both by 3? By 5? No. So that 3/5 is my final answer. Now, if you're kind of getting used to how I set notes up, you know that we're going to start with an easy problem, right? And we're going to work until they get a little bit more difficult. So I am going to tell you, as we go through the next 3 example problems, they're going to get a little bit harder. starting with this one. Now, they can be easy for you because all you guys have to do is type them to your calculator. But for note-taking purposes, show all of your work, okay? Now, you may just type it into your calculator and get the answer, but I want you guys to show the work that I'm showing. Not yet. It'll start getting colder. All right, here we go. First thing I look at, do they have the same denominator? No. So we have to find the least common multiple for 3 and 4, which we found that in our opener today. What was the least common multiple for 3 or 4? 12. So I'm going to go ahead and write that off to the side of each fraction real fast. Now, how many of you guys have multiplication charts in here? Do you all have multiplication charts? It's also easy to scan and look for what numbers have in common. So I'm going to give you a big old multiplication table that can help you out in the future too. That way you don't have to write out 3, 6, 9, 12. It's already done for you. Sorry. Go. You're welcome. Did I put one on Michael's desk? Okay, so now that we have a common denominator, we can't just change the bottom without changing the top. So I'm going to think to myself, 3 times what gets me to 12? 3 times what number equals 12? 4. Okay. Whatever I multiply my bottom number by, I multiply my top number by. So what's 2 times 4? 8. So I'm done with this old fraction here. I rewrote it. So then I go to my other fraction, 1/4. 4 times what equals 12? So then I do what from there? Multiply what? Which we got 12. So I took 4 times 3 and got 12. So now I need to get a new numerator. So I multiply my numerator by the same number. So I'm going to take 1 times what? 3 and get? Okay. So I'm done with the 1/4. So now step 1 is done. Step 1 took us a little bit of time. Now we can move to step 2. The denominators are the same, so I simply add the numerators. What's 8 plus 3? 11. Step 3, the denominators stay the same, so my denominator is 12. And step 4, simplify. Can I simplify 11 over 12? No, I can't. So this here is my final answer. Let's say that you get 11/12 and you don't know if it can be simplified or not. Type in 11, ABC button, 12, and equals. So 11, fraction button, 12 equals. It gives you the same answer, right? That tells us that it can't be simplified, that it can't be reduced. If it shows a different number, then it can be reduced. Okay, ready for example number 3? I recommend that when you're doing your notes, you're writing everything down that I am, and you're boxing your answers. Oh my goodness. With a calculator, this is easy. Without a calculator, it's not. What's wrong with this problem? Yeah. So I have a whole number, 3, minus a fraction. You can change any whole number to a fraction by doing one easy thing. How can you change any whole number to a fraction? Yeah, just put a 1 up under it. So I'm going to rewrite this just because I like things nice and neat. I'm going to rewrite this as 3 over 1 minus 1/12. Man, I wrote a lot smaller than that problem. Now I'm ready to move on to my steps. Whoops. The first step, are my denominators the same? So I need to get a common denominator. Now, if I count by ones, what's the first number that 1 and 12 are going to have in common if I count by ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What number do they have in common? Well, here's the denominator for one of them, right? I want to find the least common multiple for 1 and 12. So 12 is one of our numbers, and I'm going to skip count by 1 now. Stop me when I say the same number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah. So 1 and 12, the least common multiple they share is 12. So I'm just going to go ahead and put that 2 by that 1. But I also need to change my denominator or my numerator, right? So I have to think about 12. 1 times what got me to 12? Actually, I'm going to rewrite that. That's going to 12 times what, or 1 times what got me to 12? 1 times what equals 12? 12. So then I have to take my numerator times that same number. So it's 3 times 12. Try again. 3 times 12, not divide. You have calculators, you have multiplication tables. 36. So I'm done with my old fraction here. So now I'm ready to move to step 2. Subtract your numerators. Jalen, when I subtract my numerators, what do I get? 36 minus 1. 35. And my denominator stays the same, so what's my denominator? 12. Now, I didn't have to mess with this fraction because it already had the common denominator. So I can change just one fraction and not the other. Now I have 35 over 12. I need to see if I can reduce this. But what's different about this fraction compared to the other fractions, the answers that we got? The bigger number's on top. So when the bigger number is on top, when the numerator is bigger than the denominator, it's called an improper fraction, or excuse me, it's called an improper fraction. That was right. So when the bigger number is on top, it's called an improper fraction. Example 1 and 2, where the smaller number on top, that's called a proper fraction. And then we also have a mixed number. Now, sometimes when you have an improper fraction, they may ask you to change it to a mixed number. A mixed number is where you have a whole number with a fraction combined with it. I'm going to have you guys leave them as improper fractions. But I need to know first if we can reduce this. So can you simplify? Simplify and reduce are similar terms. Can you simplify 35 over 12? Are they divisible by 2? Are they both even numbers? Are they both even numbers? Do they both end in a 0, 2, 4, 6, or 8? Nope. Are they divisible by 3? Is 35 divisible by 3? Try it on your calculator. Take 35 divided by 3. Can you do it? No. Okay. Are they both divisible by 5? Do they both end in a 0 or a 5? No. So can you reduce these two fractions? So 35 over 12 is my final answer. Box it. Now, what I want you to do in your calculator real fast, type in 35 fraction button 12 equals. It gives you a number that looks like this, which basically means this. After you hit that, don't clear it out. Keep it in there. This is called a mixed number. The number in front of the fraction is your whole number, and then the fraction part is your fraction part. So it's called a mixed number. I don't want answers written as a mixed number. So if you get an answer like that in your calculator, how you're going to change that mixed number back to an improper fraction is by hitting the second button. So hit the second button, equals. So hit the second button, the upper left-hand corner, and then the equal sign. Oh, did it not work? Oh, it should have. Uh-oh, why did that not work? Did it work for you guys? Let me refresh my memory here. So if we have, what was it, 35 over 12, 35 fraction 12 equals 35, 12 equals second fraction. Oh, sorry. So everybody do it one more time for me. So hit 35, fraction button 12 equals, and we get 2 and 11/12, right? Okay, so what I want you to do from there is hit the second button, fraction button, equals. Now we got back to 35 over 12. So we went back from a mixed number to an improper fraction. Did we get it that time? Yeah. Okay. So you'll hit second fraction equal to get it changed back to an improper fraction. I wrote that out wrong. Okay. Ready for our last example? Last example. So we have 3/8 minus 5/6. Don't forget to box your answers. Are my denominators the same? Danielle, are my denominators the same? No. So I have to find a... On your notes. Look on your notes. Flip it over if you need to. So if my denominators are not the same, I have to find a... Common denominator. Yeah. Now, I can sit here and I can use my multiplication chart. I can find that 6, and I can find that 8, and I can slide over until I find a number that they both share. So if I look at 6 and 8, what's the smallest number that they both share? Even smaller. But that is one.
6.
Well, if I skip count by 8, I'll never say 6, will I? I'll say 8, 16, 24. So look at your multiplication chart, find where your 8 is and where your 6 is, and kind of slide over and look for what number they both have in common. The smallest number. Well, if I skip count by 8, I'll never say 12, will I? 8, 16. So find your 8 and find your 6 and kind of slide and look for the first number, because we want the least common multiple that they share. Now, we could use 24. We could use 48 because it's a multiple. The reason why you want to use the least or the smallest number they both share is because we have less to reduce then at the end. That's why we work with smaller numbers. So the smallest multiple that they share or have in common is 24. So that's going to be the new denominator. So I'm going to write that off to the side of each number. Now, if I'm changing the denominator, that means I'm going to have a new numerator as well. So first, I come here and I think 8 times what number got me to 24? 8 times what got me to 24?
4.
Try again. 8 times what number? 3, yeah. So then if I take 8 times 3 to get 24, how do I get my new numerator? What do I have to multiply together to get my new numerator? Yeah, so what's 3 times 3? 9. So whatever I multiply my bottom number by, I multiply my top number by. Okay, so I'm finished with this one. So I move to the next one. I follow the same steps. 6 times what got me to 24? Okay, if I multiplied 6 by 4 to get a new denominator, I'm also going to have to multiply my top number by that same thing. So that means I'm going to have to take what two numbers to get my new numerator? Which is 20. Okay, cross it out. All right, so I am finished with step 1. Step 1 takes forever, doesn't it? Now I move to step 2. Step 2 says to add or subtract my numerators. So here I'm going to subtract my numerators. When I subtract these numerators, what are we automatically going to see that happens? If I take 9 minus 20, what type of answer am I going to have? A negative. It is okay to have a negative fraction, okay? So what's 9 minus 20? So we're going to have negative 11 over, my denominator stays the same. What's my denominator? 24. Can I reduce 11 over 24? No, so that's my final answer. You can write, now this is something you need to remember. You can write a fraction with a negative sign, how I did right there, or you can put the negative sign right in front of the fraction bar. However, you can never put the negative sign at the bottom. That is not okay. Either this way is okay, or the way that we showed our answer. Okay? Any questions? All right, well, that's where we're going to stop for today.